Hello everybody! In this video we're going to talk about how to implement the bisect method in Matlab. If you haven't watched our video already on the mathematical introduction to the bisect method, I highly recommend you watch that first because this video builds on the algorithm that was presented in that video. So here I have a skeleton of a function. I recommend you could pause the video here and maybe get a similar function set up on your own computer to code along. But we're going to call the function bisect. And already we can see this is looking a lot more complicated than any function we've written in this class so far. So remember, to implement the bisect method, we need to input a function f, so that's what this f is here. We need a point where the function is negative, that's what we're calling x negative. A point where the function is positive, that's what we're calling x positive. And this error term, ERR, this is kind of how close do we want Matlab to get to an actual zero of the function. So this is kind of our tolerance for how far away can the point be from an actual zero. Now we're going to call the output x0, but it's important to remember that in majority of situations this is not going to be an exact zero, this is going to be an approximation. So here in a comment I basically just have a description of everything we just talked about, but basically, so given a function f, we want to find a point z such that f of a z is 0. But because there are limits to how precise a computer can be, we're going to find x0 such that the distance between x0 and the actual 0 is smaller than some error term. And the way we're going to do that is we're just going to force x0 and z to live in between x negative and x positive. So it's important to keep in mind, I don't know x negative relative to x positive. I don't know if it's greater or smaller. Because remember, all this says is that the function at this point is negative, and all x positive means is the function at this point is positive. So all we know is that x0 and z are somewhere between those 2 points. So how do we actually implement this? Well, this is a really good example of where we're going to want to use a while loop, right? Because we're going to keep iterating until we kind of meet some condition, but we don't know how long it's going to take, so a while loop is what we want to use. So I'm going to say while. Now I want the absolute value, I want the distance between x negative and x positive to be smaller than some error term, so I'm going to keep going until the distance is no longer greater than or equal to the error term. So what I mean by that is while the absolute value of x negative minus x positive is greater than or equal to our error term. So remember how we define x bisect? What we do is we just take the midpoint of x negative and x positive. So this is going to be x negative plus x positive divided by 2. Then what we do is we check. So is f of our function, is f at x bisect, is this less than 0? If it is, it becomes our new x negative. Otherwise, so this means f of x bisect is greater than or equal to 0, what we're going to do is x positive is going to be equal to x bisect instead. Now remember, why do we not have a separate case for exactly equal to 0? And that's because we don't ever expect to find a 0 exactly. So the greater than or equal to case is going to be just as good. So let's end off the for loop, or sorry, not the for loop, the while loop. And then our x0. Now we have a choice here. I could pick it to be x positive, I could pick it to be x negative. Even better is I could pick the midpoint between x negative and x positive, but I'm just going to set equal to x negative, doesn't really matter. I'm going to save my function, and now we can go try it out. So again, if any step in this process doesn't make sense, be sure to reach out for help, or go back and consult the video where we introduce bisect method. But otherwise, let's go back here. And I'm going to define a function f. Now remember, how do we do function handles? I can use @ symbol. It's going to be a function of x, and I want it to be x squared minus 2. Now, what's a 0 of this function? Well, we have one at square root of 2. So let's see how close we can get. So what I'm going to do is I'm going to say bisect, and our function is f. Now, remember, we first need to have a point where the function is negative. So if I plug in x equal to 0, 0 minus 2 is negative, so I'm going to do 0. And then I could plug in, I now need a point where it's positive. So if I plug in 2, well, 4 minus 2 is positive, so I'm going to do 0, 2. And my error term, let's say 0.0001. And we can see here that the answer is very, very close to square root of 2. So here, if I do square root of 2, I can see that's pretty cool. If I want to get even closer, I could have more precision here. And let's see, so here was our first bisect, 41418. Now we have 4142, 4142. So that's cool. We could have more zeros, get more accurate. Let's see another example, maybe with sine. So now let's say g is equal to the the function handle at sine. Now I'm going to make a mistake here. So it'd be very natural to say, well, okay, the zeros of sine are at integer multiples of pi, right? So let's say I want to find the 0 at pi. So I know pi is 3.1, ... So what if I pick 2 and 4? Because 2 is definitely less than pi, 4 is definitely greater than pi. So what's the mistake with me doing g, 2, 4, and let's just do 0.0001. So notice here the answer gives us 2. That's definitely not close to pi, or how close we'd expect. So what's going on here is, notice that this needs to be the point where sine is negative, right? But if you imagine the graph of sine, to the left of pi, like right before, it's positive, and right after it's negative. So the issue here is that the 2 and the 4 need to be flipped. So now we can see, yep, that's pretty close to pi. I could make it even more accurate by just making the error a lot smaller. So we can see here the difference between pi and what the bisect method gives is very, very, very small. So I think this is a good place to stop. In the next video, we're going to talk about Matlab's debugging mode. Otherwise, thank you for watching, and I will see you there.